Welcome to AI Pulse Trends, where we explore the cutting-edge developments shaping our technological future. Today we're diving into a critical topic that sits at the intersection of innovation and environmental stewardship: sustainable AI. As artificial intelligence transforms industries and societies worldwide, its environmental footprint is growing at an alarming rate. The computational power required for training sophisticated AI models has skyrocketed, with energy consumption reaching levels that demand our urgent attention. Consider this: training a single large language model can produce carbon emissions equivalent to the lifetime emissions of 5 average American cars. By 2030, the tech sector could account for up to 20% of global electricity consumption, with AI being a significant contributor. But here's the promising reality: the AI community isn't ignoring this challenge. From tech giants to startups, researchers to policymakers, there's a growing movement to develop AI systems that are not just powerful and innovative, but also environmentally responsible. In today's video, we'll explore the current environmental impact of AI systems, groundbreaking approaches to green computing, how companies are redesigning AI infrastructure for sustainability, the policy landscape shaping sustainable AI development, and the future outlook for balancing AI innovation with environmental responsibility. Whether you're an AI practitioner, environmental advocate, or simply curious about how technology can evolve more sustainably, this exploration of green AI will provide valuable insights into one of the most important technological challenges of our time. Let's begin. The artificial intelligence revolution has transformed how we live, work, and solve problems. But this revolution comes with environmental costs that are often hidden from view. The scale of the problem. Training modern AI systems requires enormous computational resources. The carbon footprint of developing these systems has grown exponentially in recent years. Let's look at some numbers. A 2019 study from the University of Massachusetts found that training a single large transformer model can emit more than 626,000 pounds of carbon dioxide equivalent, nearly 5 times the lifetime emissions of an average American car. The computational power used for AI training has been doubling approximately every 3.4 months, according to OpenAI research. Data centers, which power AI systems, already consume about 1 to 2% of global electricity, with projections suggesting this could rise to 8% by 2030. Energy-intensive processes. What makes AI so energy-hungry? There are several key factors. First, the training phase of machine learning models requires massive computational resources. During training, neural networks process enormous data sets through countless iterations to optimize their parameters. This process can run for days or even weeks on powerful hardware. Second, the race for more capable AI has led to exponentially larger models. GPT-4, for example, is estimated to have been trained on significantly more parameters than GPT-3, which already had 175 billion parameters. Third, the hardware acceleration required for AI, primarily GPUs and specialized AI chips, demands significant power. A single rack of these processors can consume as much electricity as several households. Beyond electricity, the full lifecycle impact energy consumption is just one piece of the environmental puzzle. AI systems have environmental impacts across their entire life cycle. Hardware manufacturing requires rare earth minerals and produces electronic waste. Water consumption for cooling data centers constrain local resources. Data storage facilities occupy physical space that might otherwise serve natural habitats. Network infrastructure, enabling cloud-based AI, consumes additional energy. The environmental impact of AI is particularly concerning because it's largely invisible to end users. When we ask a virtual assistant a question or use an AI-powered service, we don't see the massive data centers powering these interactions. Case study. Language models. Let's examine a concrete example. Large language models, like those powering modern chatbots. Research from 2022 estimated that training a state-of-the-art language model produced roughly 300 tons of CO2 equivalent emissions. For context, that's about the same as 70 gasoline-powered cars driven for 1 year. Even more concerning is that researchers often train multiple versions of these models before arriving at the final version, multiplying this impact several times over. However, it's important to note that once trained, the operational carbon footprint of these models decreases significantly. The inference phase, when the model is actually being used, consumes far less energy than training, though it still adds up at scale. Facing these environmental challenges, the tech industry has begun developing solutions that could dramatically reduce AI's carbon footprint while maintaining its innovative potential. Efficient hardware architecture, hardware optimization, represents one of the most promising approaches to sustainable AI. Specialized AI chips designed for energy efficiency are emerging as alternatives to general-purpose GPUs. Companies like Google have developed custom TPUs, tensor processing units, that can deliver more AI computations per watt of power. Neuromorphic computing, which mimics the brain's neural structure, shows potential for dramatically lower energy consumption. Photonic computing uses light instead of electricity, potentially reducing energy needs by orders of magnitude. Software optimization techniques. On the software side, researchers are finding ingenious ways to do more with less. Model compression techniques can reduce AI models to a fraction of their original size while maintaining most of their capabilities. Knowledge distillation transfers the capabilities of large, complex models to smaller, more efficient ones. Neural architecture search automates the discovery of efficient model designs. Federated learning distributes computation across devices, potentially reducing centralized data center demands. Case study: Google's AI efficiency gains. Google reported in 2020 that they had achieved a 4x improvement in energy efficiency for their AI systems through TPU development and algorithmic improvements. Their data suggests that for the same computational task, their newest systems use just 25% of the energy required by their previous generation hardware. Renewable energy integration. Beyond making AI more efficient, companies are working to power their operations with clean energy. Microsoft committed to shifting their data centers to 100% renewable energy by 2025. Apple claims that all their facilities worldwide already run on 100% renewable electricity. Google has pledged to operate all their data centers and campuses on carbon-free energy by 2030. Amazon Web Services, a major provider of cloud computing for AI, has committed to powering their operations with 100% renewable energy by 2025. These initiatives demonstrate that renewable energy is becoming central to sustainable AI development. However, challenges remain in ensuring round-the-clock clean energy availability and building data centers in locations that can access abundant renewable resources. Carbon-aware computing. An emerging approach called carbon-aware computing schedules computation to minimize carbon impact, shifting non-urgent AI training to times when renewable energy is plentiful, moving computations to data centers in regions with cleaner energy mixes, dynamically adjusting computational intensity based on the carbon intensity of available power. Microsoft has pioneered this approach with their carbon-aware cloud services, reporting emission reductions of up to 60% for flexible workloads. Major tech companies are redesigning their AI infrastructure with sustainability in mind, setting new standards for the industry. Data center innovations. Data centers are being reimagined with environmental considerations at the forefront. Advanced cooling technologies like liquid cooling systems are replacing traditional air conditioning, reducing energy needs by up to 40%. Heat recovery systems capture waste heat from servers to warm offices or nearby buildings. Location optimization places new data centers in cooler climates or near renewable energy sources. Modular, scalable designs allow for more efficient resource utilization. Corporate commitments. Leading AI companies have made bold sustainability commitments. OpenAI partnered with infrastructure providers committed to renewable energy for their model training. DeepMind applied their AI to optimize Google's data center cooling, reducing energy use by approximately 40%. Microsoft pledged to be carbon negative by 2030 and to remove all historical carbon emissions by 2050. NVIDIA developed efficiency metrics for their AI processors, allowing developers to make environmentally informed hardware choices. Measuring and reporting transparency is becoming a competitive advantage as companies develop standardized ways to report the environmental impact of their AI systems. Carbon footprint reporting for AI model training is becoming more common in research papers. Energy efficiency benchmarks specifically for AI workloads are being developed. Lifecycle assessment tools help quantify the full environmental impact of AI systems. Economic incentives market forces are beginning to align with environmental goals. Energy costs represent a significant expense in AI development, creating financial incentives for efficiency. Cloud providers now offer green options with premium pricing for environmentally conscious customers. Carbon pricing mechanisms in various regions make energy-intensive computing increasingly expensive. Investor pressure pushes companies to improve their environmental performance. The business case for sustainable AI is strengthening as consumers, investors, and regulators all demand greater environmental responsibility. As awareness of AI's environmental impact grows, policymakers worldwide are developing frameworks to encourage sustainable development. Regulatory approaches. Several regulatory initiatives aim to address the environmental impact of digital technologies, including AI. The European Union's Green Deal includes provisions for digital sustainability. Energy efficiency standards for data centers are being implemented in various jurisdictions. Carbon pricing mechanisms apply indirect pressure on energy-intensive AI operations. Disclosure requirements for large companies increasingly include technology-related emissions, industry standards. The tech industry is developing its own sustainability standards. The Green Software Foundation establishes principles for environmentally sustainable software. MLPerf, a benchmark suite for machine learning, has begun incorporating energy efficiency metrics. IEA has launched working groups focused on sustainable computing standards. The Climate Change AI organization is developing best practices for measuring and mitigating AI's environmental impact. The role of public research. Government-funded research is accelerating progress towards sustainable AI. DARPA's Electronics Resurgence Initiative includes funding for energy-efficient AI hardware. The European Commission has directed research funding towards sustainable computing. National laboratories are developing next-generation computing architectures with efficiency in mind. International collaborations are establishing open standards for measuring AI energy consumption, balancing innovation and regulation. The challenge for policymakers is encouraging sustainability without stifling innovation. Too stringent regulations could push AI development to regions with less environmental oversight. Insufficient guidance could allow environmental impacts to grow unchecked. The optimal approach likely combines incentives, standards, and targeted regulation. The most effective policies will likely work with market forces rather than against them, accelerating the adoption of technologies and practices that are both innovative and sustainable. Looking ahead, several trends suggest promising directions for environmentally responsible AI development. Emerging technologies. New approaches on the horizon could fundamentally change AI's environmental equation. Quantum computing, while still in its early stages, could potentially solve certain problems with vastly lower energy requirements. Analog AI computing shows promise for drastically reduced power consumption. Reversible computing architectures might theoretically approach the fundamental thermodynamic limits of efficiency. Biological computing, inspired by the extraordinary efficiency of the human brain AI for environmental solutions. Ironically, AI itself may be key to solving the very environmental problems it contributes to. AI optimization of power grids can increase renewable energy utilization. Climate modeling powered by AI improves our understanding of environmental systems. Smart building systems reduce energy consumption through intelligent management materials. Science, accelerated by AI, could lead to better solar panels and batteries. The potential environmental benefits of well-directed AI applications could far outweigh their costs, but this requires intentional development focused on sustainability. Systemic changes beyond technological solutions. Sustainable AI may require broader systemic changes, shifting from a model of continuous growth in AI capabilities to one that values efficiency, developing better metrics for AI performance that include environmental impact, creating economic incentives that reward sustainable AI development, building a culture of environmental awareness in the AI community. Ethical considerations. The environmental impact of AI raises profound ethical questions. Who should bear the environmental costs of AI development? How do we ensure equitable access to AI benefits while minimizing global environmental harms? What responsibility do AI developers have to consider environmental impacts? How should we balance immediate benefits against long-term environmental sustainability? These questions have no easy answers, but they must be part of the conversation as we shape the future of artificial intelligence. As we've explored throughout this video, the environmental challenges posed by AI development are significant, but so too are the opportunities for creating more sustainable systems. The path forward requires a multifaceted approach. Technical innovation in hardware and software to reduce AI's energy demands, corporate leadership that prioritizes environmental responsibility alongside capabilities, policy frameworks that encourage sustainable practices without stifling innovation, research directions that explore fundamentally more efficient approaches to artificial intelligence. Most importantly, we need a shift in how we think about AI progress. The most advanced AI may not be the one with the most parameters or the largest training dataset, but rather the one that achieves remarkable capabilities while treading lightly on our planet's resources. The stakes could hardly be higher. AI promises to help solve some of humanity's most pressing problems, from climate change itself to healthcare and scientific discovery. But if its development comes at a severe environmental cost, we risk undermining the very future we're trying to build. The good news is that the AI community is increasingly recognizing this challenge. From research labs to tech giants, from policymakers to students entering the field, sustainability is becoming a core consideration rather than an afterthought. This represents a profound maturation of the field, an acknowledgement that truly intelligent systems should be designed with awareness of their full impact on the world. The sustainable AI mindset. As we close this exploration of sustainable AI, I invite you to adopt what we might call a sustainable AI mindset. Question the environmental implications of AI systems you use or develop. Look for opportunities to make AI more efficient in your own work. Support organizations and policies that prioritize sustainable technology. Consider the full life cycle impact of AI, from manufacturing to operation to disposal. By bringing these considerations into our relationship with artificial intelligence, we can help ensure that this revolutionary technology enhances rather than endangers our planetary home. Thank you for watching this episode of AI Pulse Trends. If you found this exploration of sustainable AI valuable, please consider subscribing to our channel for more insights at the frontier of technology and society. What aspects of sustainable AI are you most interested in learning more about? Let us know in the comments below. Until next time, stay curious and stay sustainable.